Raw steel becomes a giant connecting rod here. It is heated and forged with extreme force. Then precise center openings are formed. The surface is cleaned. But this is not a quick job. This heavy-duty rod is built for big machines. In large engines and heavy equipment, it helps transfer massive force. Because it is custom-made, the process is far from ordinary. This is the forging die that shapes the rod. The die weighs nearly 2 tons. It must be hard, tough, and wear-resistant. For custom work, small batches need their own process. Every design is different, so the factory cannot use one standard die for every job. For each forging die, the tools and setup must change. That raises the production cost and also adds more time. Take this machining step here. Even before forging begins, die work can take over 2 hours. The steel chips may weigh over 100 pounds. Every part of the job is watched closely by skilled operators. Now the shape is becoming clear. The rod is taking form, even near the raised areas. The surface must stay clean and accurate. The factory requires tight precision. The more accurate the die, the better the final forging. But this is not the final shape. Before moving forward, burrs and rough edges must be removed. Meanwhile, another shop prepares the raw steel. Ordinary steel is not enough here. So the factory uses a special alloy, chosen for strength and toughness. This steel is made for demanding parts. Its key advantage is working under extreme conditions. Heat, cold, impact, and load all matter. It also resists tempering brittleness, so similar steels are used in gears and shafts. That makes it suitable for heavy engine parts. But these long bars cannot be used as is. They must be cut. Each section is cut to under 2 meters. Because the cut is controlled, the cross-section stays smooth and even. Next, the pieces are grouped in batches of 18 and loaded with careful spacing. This prepares them for heating. 5-meter tongs grip the steel first. Then it enters the furnace. Once the target heat is reached, the glowing steel is pulled out. Hot forging may look simple, but it is tightly controlled. The first challenge is temperature. For hot forging, the steel stays above 1,150 degrees Celsius. At this heat, the structure changes. Carbon and alloy elements spread more evenly. With each hammer strike, the rigid steel begins to flow into the die shape. Oxide scale breaks off like snow. It is harsh but remarkable to watch. The nearby operator controls the whole motion. Every small adjustment guides this multi-ton machine with surprising precision as the steel stretches and widens. It enters the main shaping stage. The operator uses aligned upper and lower gripping tools. Once the piece is held, the hammer brings it closer to size. Length, width, and thickness are controlled here. Every move must be timed right. When the section reaches length, the operator flips it and works the other end. This leaves material for the big end. The big and small ends have different jobs, but both need high accuracy. One holds a larger bearing surface. Inside an engine or heavy machine, the rod becomes a key load-bearing link. It must survive force, heat, and vibration. Its shank can be as thick as a man's arm. To get a proper forging, controlled cooling is important for every rod. This is not just for convenience. It helps control the metal structure. Only after proper cooling can it move to the next heating stage. This time, the heat rises again, and the pace becomes faster. Once it passes 1,200 degrees Celsius, the machine removes it right away. Then it goes on to the conveyor. At this temperature, no worker can touch it directly. Every required movement is handled by machinery. This keeps workers at a safer distance. Look at the pieces below. These heated sections of the alloy steel prepared earlier. The step may look simple. The steel is set on the die and kept level. But two workers must coordinate closely. One positions the rod, while the other clears away scale. Each impact throws sparks across the area. For a moment, the room lights up. The smoke and heat show how demanding this is. Up close, the force is even easier to see. The drop hammer weighs about 8 tons. That does not include the huge anvil below. Counting the whole system, it can exceed 100 tons. In the past, work like this was far less controlled. It relied on strength and experience. Today, machines carry the force, but skill still matters. Once the rod is moved out, it goes to a second stamping platform. This station trims excess material during the earlier forging. Sharp flash forms around the edge. Only after this flash is removed can the rod match its outline. At this stage, the part is close to its forged size. But one important step still cannot be skipped. That is surface cleaning. When steel first leaves the heat, it glows bright red, but after cooling, the surface turns dark, rough, and covered with scale. This is normal after forging. Almost every forged steel part faces the same surface issue. So the next key step is shot blasting. This cleans the surface and removes the oxide layer. After 8 rods are loaded, the worker closes the heavy steel door. Inside, high-speed steel shot strikes the rods again and again. The result appears almost immediately. The rods come out clean and ready for machining. Now take a closer look. These are the pieces loaded earlier. Only 8 pieces are processed at a time. With enough space between them, the blasting reaches every corner and cleans the surface evenly. If too many parts are loaded, the cleaning will be uneven. This small detail also saves labor. Workers no longer scrub each part by hand.